Hello ma'am, so for today, we will be discussing about the limits of an algebraic function. So for example, number 1, we put there the limit of 5x cubed minus 4x squared plus x minus 8 as x approaches to 2. So as we all know, if you see a polynomial, you can already use direct substitution here. Direct substitution, which means you can input the x approaches to 2 in every x present in the terms. But what I did was get the limit of each term first. So it goes like this. The limit of 5x cubed minus the limit of 4x squared plus the limit of x and minus the limit of 8. All of them as x approaches to 2. After that, we substitute the x into all the x variables here. So that would be equal to 5. We substitute the x to here in the x, that would be 2 raised to 3 minus the limit of 4x squared minus 4 times 2 raised to 2 and plus 2 because it's just an x here. So this is the x. As x approaches to 2, you just input it here and the constant remains as a constant. So after that, 2 raised to 3 is 8, you just copy 5, minus 2 raised to 2 is 4, copy 4, and just copy the two remaining given terms. So 5 times 8 would be equals to 40. 4 times 4 would be 16, and just copy 2 and minus 8. So if we all input this in our calculator, or we solve this, all of them, it would be equal to 18. So for example number 2, on the limits of an algebraic function, you can see here we have a rational function. It says here the limit of x cubed plus 2x squared minus 3x minus 8 all over x squared minus 4x minus 1 as x approaches to 3. So there's a certain trick here that we can use when solving rational functions like this. The trick is we solve first the denominator using direct substitution to see if it gives us 0, which would be indeterminate, or if it gives us a number, so that we can also use direct substitution on the numerator. So for example, we use direct substitution here on the denominator. That would be equals to we substitute the x variable with x approaches to 3, all the x variables in the denominator. So that would be 3 squared minus 4 times 3, because substitute x approaches to 3 here, and minus 1. So that would be equal to 3 squared would be 9, 4 times 3 would be 12, and minus 1. So if we all solve this, it would be equal to negative 4. Proceeding, if we had a number, if we solve the denominator, we can that also means we can use direct substitution on the numerator. So we will use the direct substitution on the numerator. So it goes like this. As what we did on the denominator, we just substitute here the x approaches to 3 to all the x variables. That would be 3 cubed plus 2 times 3 raised to 2 and minus, that would be 3 times 3. Just copy here the 8 because it's constant. There's no x variable here that can be replaced by x approaches to 3. And the denominator also, we copy the denominator, which we solved earlier, is 3 squared minus 4 times 3 minus 1. Proceeding, 3 cubed would be equal to 27, 2 times 3 raised to 2 would be equal to 18, and negative 3 times 3 would be negative 9, and minus 8 all over 3 squared is equals to 9, minus 4 times 3 would be 12, and minus 1. So that would be equal to 28 all over 4. Or if we still try to simplify this, that would be equal to negative 7. So as you can see, proceeding to our next topic would be the trigonometric function limits. So for example number 1, we have here the given 9 times 1 minus cosine x all over x. So how do we solve this as x approaches to 0? How do we solve this? So as we can remember, we have a law that states 1 minus cosine x, this 1 minus cosine x all over x would be equals to 0. So how do we solve this? Because we have a 9. So what are we gonna do is we're gonna separate 9 from all of the terms given. So that will be 9 times the limit of 1 minus cosine x all over x as x approaches 0. As we know, this part, the limit of 1 minus cosine x all over x as x approaches 0 is automatic, is equals to 0. So what are we gonna do is put this as a 0 and just copy our 9. So that will be equal to 9 times 0 is equals to 0. So example number 2 would be the limit of sine times 3x all over 5x is equals to 3 over 5. We can already see here that this is equals to 3 over 5. So how are we gonna do to prove this? What are we gonna do to prove this? So let's put it this way. So the limit as x approaches 0, sine 3x all over 5x, we will multiply this 2 by 3 because it's still the same when 5 times 8. And proceeding, a limit of sine 3x all over 3x as x approaches 0 times 3 over 5. So don't get confused why is it already 3x here. We just put the 3 here and put the 5 over here. So as you can notice, there are the same variable. We have the same variable already or the given terms. So we can put y as 3x. So as we remember, there's a law stating that limit is supposed to be sin x over x. For this, we're gonna put y because our y is 3x. The limit of sin y all over y as x approaches 0 is equal to 1. This is equal to 1 because it's stated in the law that if this is the given, it is equal to 1. So this is supposedly 1, and we multiply it by 3 over 5. So that will be equal to 1 because this is 1 times 3 over 5, which is equals to 3 over 5. So if we check it, we have the same answer. So going back to our topic, we finished on limits of algebraic function and the limits of trigonometric functions. Now we're proceeding to difference quotient. So the difference quotient has a formula. This is his formula: f of x plus h minus f of x, or the function, all over h. So number 1, we are given here f of x is equals to 9x. So how are we gonna solve this? Using the formula, we can just input here 9 times x plus h minus f of x. F of x is 9x all over h. Don't forget the h. And what we're gonna do is distribute the 9 to the x and h because it's in parentheses. So 9 times x, that would be 9x, plus 9 times h, that would be 9h, and minus the function, which is 9x all over still h, equals to, as you can see, we can simplify it here. We have two 9x's, you can cross them out. So the only one remaining would be 9h and h. So 9h over h. We can also cancel the h because they are equal to 1. That would be equal to 9. So on example number 2, we can see here we have the function equals to 7x plus 5. So using the formula earlier, which we said, f of x plus h minus f times x plus h minus f of x all over h. So what we're gonna do is we're gonna put the 7 outside because it's stated that's only x plus h on the inside. So that will be 7 x plus h and also the plus 5 minus the function, which is 7x plus 5 all over h. So we're gonna distribute 7 on the parentheses. So 7 times x would be 7x plus 7 times h would be 7h, and don't forget the plus 5 minus the function, which is 7x minus 5. As you can see, why it became minus 5, because we distributed the negative sign. So that would be already negative 7x minus 7 5 minus 7x and 7 5 all over h. So we can cross similar terms or like terms, 7x and 7x, and positive 5 minus negative 5 would be equal to 0. So cross that out. So we're gonna only remain with 7h all over h. So this is it. And as what we did on the other example earlier, we just crossed out h because it's equal to 1. That will be only equal to 7. So proceeding, we are now at the derivative of a algebraic function. So we have here the derivative of 6x cubed. So how do we get the derivative of 6x cubed? So there's a here formula or a law that states that the derivative of a constant times the function, this is the function, this is the constant, 6 is the constant, is equal to the constant times the derivative of the function. So proceeding, we're gonna input here are given, so that will be the derivative of 6x cubed. So we're gonna use the formula, which is the constant, which is the 6 is our constant, times the derivative of the function, which is x cubed. Now what are we gonna remain is 6 times the derivative of x cubed is 3x squared. Why 3x squared? Because we just transfer the 3 here. It's automatic, there's a 1 here, so 3 times 1 is still 3x, and the exponent here should be there's a minus 1 here if you transfer it, so that becomes squared. And if we try to solve this, that will be equal to 18x squared. So proceeding on our example number 2, as you can see, this is quite easy pero it's tricky. So f of x is equals to x cubed times the x to the 4th plus 8. So how are we gonna solve this? So what we're gonna do is distribute the x to the parentheses. So x times x cubed times x raised to the 4 would be x raised to 7. Why x raised to 7? Because it's understood that in our laws of exponent, you just write the same base and add the exponents. So that would be 3 plus 4 would be 7, plus x cubed times 8 would be just 8x cubed. So in getting the derivative of our function, because we simplified this would be the so in getting the derivative of this function, we're gonna use the different derivative rules. For example, the exponent rule on derivatives, which states that you just transfer the exponent to the side of the x, and you minus 1 here. There's a formula for that, so we need to review about it, or we should know it already by now. And what we did here, that would be 7 x raised to 6 plus 8 times 3x squared, because the derivative of x cubed is 3x squared. That would be equal to 7x raised to 6, and 8 times 3 would be 24x squared. So we're back with another topic. So this topic is called the derivatives of a logarithmic function. So we have a given here, the derivative of ln times 4x cubed plus 3. So our formula here would be 1 over the function. This is u here, which is also known as the function, or it's written like this, 1 all over the function times the derivative of u, which is the function, all over dx. So 1 over the function is 4x cubed plus 3 multiplied by the derivative of a function. So this is our function, 4x cubed plus 3. And if we try to get the derivative of 4x cubed plus 3, that would be 12x squared. Because we just transfer the 3 here as we stated on the laws of derivatives. And 4 times 3 would be equal to 12. And the 3 here, we just subtract 1. That would be 2. And if you notice, there's already no 3 here because it's stated that in the laws of derivatives, the constant is always equals to 0. So we will try to simplify this. So that would be equal to 1 here as 1 over the function, which is the 4x cubed plus 3, multiplied by the derivative of the function, which is equal to 12x squared. So I'm going to simplify this. That would be 1 times 12x squared is 12x squared all over 4x cubed plus 3. Proceeding to our next example on the derivative of logarithmic functions. So we are given here the derivative of ln, or natural log x to the fourth. So the derivative of a ln x raised to fourth is, we just simply transfer the 4 on the front. So 4 ln 4 times ln, that's read as 4 times ln x, because we're gonna know later on after onwards. So is equals to 4 times, this is the what do you call this, the formula, times the derivative of the function. I'm sorry, I forgot to put x here. Oh, nag-asterisk na siya. The derivative of the function which is ln x our function. So that would be equal to 4. As we all know, the derivative of ln x is 1 over x. 4 is 1 over x, because times derivative of ln x is 1 over x, s equals to 4 over x. So for our last topic, we're gonna discuss about the derivatives of exponential functions. So in this certain topic, I've used the formula, the derivative of e raised to a function is equals to e raised to a function times the derivative of the function. So we are given here, example number 1, the derivative of e raised to 6x plus 4. So how do we solve this? Using our formula, e raised to the function is equals to e raised to a function times the derivative of the function. So that would be equals to e raised to the function times the derivative of the function, which is x. So it's 6 because it's 6x here. So 4 is not already included because it's a constant. Because on the rules of derivatives, a constant is always 0. That would be only 6. And I multiply them. That would be equals to 6e raised to the function, which is 6x plus 4. So proceeding in our example number 2 on the derivatives of exponential functions, we are given here the derivative, I'm sorry, this is x. This is x, not v. The derivative of e raised to the function x raised to the fourth plus 6x. So, as we all know, we have a formula that we use. This is our formula. The derivative of e raised to a function is equals to, we just copy the e raised to a function times the derivative of the function. That would be equal to e raised to the function, which is x raised to the fourth plus 6x multiplied by the derivative of the function. So don't get confused, because the derivative we're just gonna get the derivative here on top, because that's just our function, or our f of x. So the derivative of x to the fourth would be 4x raised to the third, or 4x cubed, plus the derivative of 6x would be just 6. And we're gonna multiply them. That would be equal to 4x cubed plus 6 times the e raised to the x to the fourth plus 6x.